Welcome to Knowledge Catch. Today we shall discuss binary addition and subtraction. Before moving further, let's have a quick overview of the binary number system. The binary number system. It is a positional weighted system with base or radix equal to 2. Its symbols include 0 and 1 with each of the binary digit called a bit. In the binary number system or in a binary number, the binary point separates integer and the fraction parts. Consider a binary number as shown here. Here, the leftmost bit is called the most significant bit or MSB, whereas the rightmost bit is called the LSB or the least significant bit. Here, the positional weights or the place values are assigned as shown here. The LSB, since it is the least significant bit, is assigned the least positional weight or place value equal to 2 raised to 0, which is equal to 1. The next bits are given the place values 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, and so on. The highest place value or the positional weight is assigned to the MSB. The rules involved in binary addition are as follows. Just as in decimal addition, 0 plus 0 equal to 0, 0 plus 1 is equal to 1. In binary addition, 1 plus 1 is equal to 0 with the carry equal to 1. Here C denotes the carry. The truth table. Truth table is a mathematical table used in logic and computer science to show the possible truth values of a logical statement or expression for every possible combination of its input variables. The truth values can be either true or false or 1 or 0. So in this case, we are considering the 1-bit addition. For every possible combination of the input A and B, we are computing the sum S and the corresponding carry involved. So in this case, as we have seen from the rules, 0 plus 0 is equal to 0 and the carry obtained is 0. The next case, 0 plus 1 will give you the sum equal to 1 and the carry is 0. Next combination is 1 plus 0, which again gives a sum of 1 and carry equal to 0. Just as we have seen in the rules, 1 plus 1 is equal to 0 with the carry equal to 1. Now let's see some examples for 2-bit addition. So in this case, it's 0, 1 plus 1, 0. Starting from the LSB, we get 1 plus 0 is equal to 1. And 0 plus 1 again equal to 1. So the answer is 1, 1. Next example, 0, 0 plus 1, 0. So again here 0 plus 0 is equal to 0 and 0 plus 1 is equal to 1. The next case, 1 plus 0 equal to 1, but 1 plus 1 is 0 with the carry 1. Now let's consider this example, that is 1 1 plus 1 1. So starting from LSB, we get 1 plus 1 equal to 0 with the carry equal to 1. Again, 1 plus 1, we get 1 0, that is 0 with the carry 1. Now again adding this 1 over here, you get 1 0 plus 1, that is 0 plus 1 1 and the carry 1. So the final answer is 1 1 0. Now we shall see some examples of multi-bit addition. So this one, That is 1011 plus 1000. Starting from LSB, we have 1 plus 0 equal to 1, 1 plus 0 equal to 1, 0 plus 0 equal to 1. As in the rule, 1 plus 1 is 0 with a carry 1. Now let us consider the addition of two fractional or mixed binary numbers. Starting from LSB, we have 1 plus 1 equal to 0 with a carry 1. This one is added with this bit to get 0 with a carry 1. And this one is added with this bit to get 0 with a carry 1. Then 1 plus 1 is 0 with a carry 1. And again, this 1 is added here. So we get 1 0 plus 1, that is 1 1. That is 1 with a carry 1. And this is again added with 1 to get 0 with a carry 1. So again, 1 plus 1 is 0 with a carry 1 plus this 1. So we get 1 1. This 1, the carry 1. This one is added with this, get 0 with the carry 1. So the final result is 10101.000. Some of the points to remember while performing the binary addition are: always start the addition from the LSB, and 1 plus 1 always generates a carry. These are some of the problems that you can work out. Next, we have the binary subtraction. These are the rules involved in binary subtraction. It is similar to decimal subtraction, where we have 0 minus 0 is equal to 0, 1 minus 1 is equal to 0, 1 minus 0 is equal to 1. In binary subtraction, 0 minus 1 is equal to 1. That means the difference is 1 and the borrow is equal to 1. We always subtract a lower bit from a higher bit, that is 0 from 1, else a borrow is involved. Also in binary subtraction, 1 0 minus 1 is equal to 1. Consider this number 1 0. When we assign the place values to the LSB, we are assigning 2 raised to 0, and to this bit we are assigning 2 raised to 1. We are trying to convert this 1 0 to the decimal equivalent. We get 1 into 2 raised to 1 is equal to 2. That means the decimal equivalent of 1 0 is 2. Similarly, when we try to convert this 1, similarly when we try to convert this bit 1, we get the decimal equivalent as 1. That is, assigning the place values, we get 1 into 2 raised to 0, which is equal to 1. So this operation, that is 1 0 minus 1, is equivalent to 2 minus 1, which is equal to 1. Again, the decimal 1 and the binary 1, both are counterparts. Hence, we get 1 0 minus 1 equal to 1 in binary as well. This is the truth table of 1-bit binary subtraction. Here x and y denotes the inputs. D is the difference and B is the borrow. So 0 minus 0 gives the difference of 0 with the borrow equal to 0. Next, 0 minus 1. Here the difference is 1 Since x is less than y, we get a borrow of 1. Next case, 1 minus 0, the difference is 1. Here x1 is greater than 0, hence there is no borrow involved. That is b is equal to 0. Next, 1 minus 1, here the difference is 0 and the borrow is again 0. Let us try to subtract the binary number 10 from 1000. So we take the largest number and subtract the smaller number 10 from it. Starting from LSB, we have 0 minus 0, which is equal to 0. Here again, it is 0 minus 1. Here, 0 is less than 1. We need to borrow. So, we borrow from this number 1 to this digit. And this 0 becomes 10. And this becomes this one becomes 0. And from this 10, 1 is given to this 0. So this 0 becomes 10. And 10 minus 1 is equal to 1. We have seen this already. Now, we already gave a borrow of 1 to this 0 or to this bit. So this 10 becomes 10 minus 1, which is equal to 1. So again we perform 1 minus 0, which is equal to 1. Here it is 0 minus 0, which is equal to 0. So the result of subtraction of 10 from 1000 is 0110. Just to check our result, we can verify it using the decimal system. So this 1000, this is equivalent to 8 because 1 into 2 cube, which is equal to 8. Then this 10, that is 1 into 2 raised to 1, which is equal to 2. Then 0110, that is equivalent to 1 into 2 square plus 1 into 2, that is 4 plus 2, which is equal to 6. So 0110 is equivalent to 6. So here if we see 8 minus 2 is equal to 6, that is what we have obtained here, and hence we have verified our result. Now we shall try to subtract 111.111 from 10100.01. Let's start with the LSB. So this number 0 is less than 1. So borrow needs to be done from this bit to here. After the borrow, the LSB becomes 10. And since borrow was performed from here to here, this 1 becomes 0. Now, Here we perform 1 0 minus 1. 1 0 minus 1 is equal to 1. We get a 1 here. You have already seen that 1 0 minus 1 is equal to 1. The next step, we try to subtract the 0 minus 1. Again, the 0 is less than 1, hence borrow has to be done from this one to this. What happens is that 1 is borrowed from this position to here, so it becomes, this 1 becomes 0 over here, and the 0 becomes 1. Get 1 0. Similarly, from here 1 is borrowed to this position, from here to this position. So the borrow was performed from this bit position to this bit position, so that this one becomes 0 and the 0 becomes 1 0. Now borrow is to be performed from this bit position to this bit position, such that this bit becomes 1 0, and at this bit position 1 0 will become 1 0 minus 1 is equal to 1. The next step, borrow is to be performed from this 1 0 to this position, such that here the 1 0 becomes 1 0 minus 1, which is equal to 1, and the 0 becomes 1 0. Now in order to perform 0 minus 1, borrow has to be done from this bit position to this position, so that here it becomes 1 0 minus 1 equal to 1, and this bit position number becomes 1 0. Now at this position we are able to perform the subtraction, that is 1 0 minus 1, which is equal to 1. Here 1 minus 1 is equal to 0. Again 1 minus 1, we have 0. Here also 1 minus 1, we have 0. Here we are having 0 minus 1, which means that the 0 is less than the 1 over here. Hence we have to perform the borrow operation from this position, which means this 1 is borrowed to this position first, such that this 1 becomes 0 and this 0 becomes 1 0. Again from this 1 0, borrow is done to this position, such that 1 0 minus 1 becomes 1 over here. Here we get 1 0. Now at this bit position we have 1 0 minus 1, which is equal to 1, and again 1 minus 0 is equal to 1, and at the extreme left we have 0 minus 0 equal to 0. So this is the final result of the subtraction. Hence the result of the subtraction we obtain is 0.011. These are some of the key points to remember while doing binary subtraction. Remember to always start from LSB, and 1 0 minus 1 is equal to 1. These are some of the problems that you can work out. Thank you for watching this video. If you have liked this video, please give a thumbs up and do share it with your friends. And make sure to subscribe our channel. Thank you.